Hello folks, good morning. 안녕하세요. How are you? I'm going to wake you up a little bit. We're going to try something that I like to do sometimes. I'm going to take a photo of you, and I want you to say cheese while I take this panoramic picture, okay? I just want to get your attention, kind of get you going. All right, say cheese. Cheese. All right, we're going well. Cheese. There we go. That's turning into a pretty good picture. Maybe I will share with you, Christine. Gotta use mobile, you know. Gotta be mobile. So, so what I want to talk to you today is what type of customer problems we spend our day-to-day at Aruba trying and solve. I've been part of the Aruba organization since 2004. So I've been with the company for 11, getting close to 12 years. And during the early days of the company, we really had it rough. It was a tough time for us. Nobody wanted to buy Wi-Fi solutions. Everybody thought that it was insecure. Nobody really cared about cloud-based applications. People didn't even know what cloud was back in the day. But we said, you know what, this is going to be really important. People are going to be taking their work home and to trains and to airports and airplanes, and everybody looked at us like we were crazy. Okay? Thankfully, we were right. Many of the other market trends, market changes helped us grow over the years. So I'm going to try to tell you where we are today in terms of the technology adoption of mobile devices, mobile apps, and cloud-based systems that support that transformation in our work lives. So let me give you a quick picture. We're using our mobile devices today, laptops, or any type of digital device that we might be interacting with at home. Maybe some of them are IoT devices. Imagine those devices without cloud-based systems, cloud-based services that you can access immediately. Imagine what those devices would look like. They will be pretty dumb. They will be just another brick. They won't be very exciting. There will be no Facebook. There will be no Amazon. There will be no Skype. There will be no Dropbox. Without cloud, mobile doesn't exist. If you do not have mobile, let's assume a world where the cloud-based applications and systems are all around us. Data centers, private and public, hybrid infrastructures. We're deploying apps in containers and in servers and VMs. But we don't have any mobile devices or IoT devices to take advantage of those resources. Cloud will not be what it is today. So that's why we, as HPE Aruba, are in the business of connecting the two pieces of the puzzle. Does that make sense? I have cloud-based apps and systems that make mobile devices work and IoT possible, and I have mobile and IoT that pushes even more innovation in the cloud infrastructures. And somebody needs to connect the two. That's us. In the past, you used to have traditional networking infrastructures that did something very similar, but within the confines of four walls. You had an IT server room, and you had your desktop PCs and printers. We called that the local area network. Clearly, that world has changed. We no longer have desktop PCs and printers and just IT server rooms. We have much more. So we provide a different networking technology to enable that transformation. I'm going to give you, here's how the presentation is going to go. Quick heads up. First, I'm going to talk to you about what's putting pressure on IT networking. What are the things that really bug us, give us headache, give us a pain point as we try to do our daily jobs? To reference, I studied computer networking when I was in school. I learned all about local area networking, but the things that we need to do today are far beyond what I was trained on many years ago. Next, I'm going to talk to you about what type of headaches does that cause for IT networking organizations like yourselves. What are these market trends mean for you? In the campus, branch, and remote networking, which we call mobile first, and in the data center, cloud first. And then, I'm going to tell you how we solve those pain points. What are the aspirins we have for your headache? Okay, 3 pieces. Market trends, your pain points, we think, and what are our aspirins. So the first problem is humans. The first problem are the people. Okay, it's a good problem. So first, we have 2 personalities. Our first personality is what we regard as Gen Mobile. If we are a young student at school, we do not know what a traditional phone looked like. We just do not even know a world without a touch screen. Your kids live in a world where a touch screen is just the normal. So clearly they want to learn using digital devices that they can touch, they can feel, they can interact with their student partners and students. Next comes, for example, doctors. Instead of carrying pen and paper wherever they go in a hospital or go travel between clinics, they would love to have patient information, colleagues' information, patient data directly on a digital device. They do not want to carry pen and paper anymore. It's understandable. Marketing people, like myself, we have always went after the attention. When people used to read newspapers, we would put advertising onto the newspapers. When they would watch TV, we will put advertising on the TVs. Let me see a show of hands. How many of you fast forward advertising on TV when you see it? Fast forward through advertising, right? Lots of people, I myself included. Nobody watches TV advertising anymore. If you don't even watch TV advertising, what do? As soon as there's an ad comes out, you pull this up and you look at Facebook. Or you chat with your friends on Kakao. I learned that that's your social chat app. So what do we do now? As marketeers, when people show up in our venues, at a shopping mall, or at an airport, or at an event, we immediately want to attack what's in front of people's eyes. We want to attack the smartphone. So marketing people care about engaging with their customers and visitors on their smartphones and not on paper and TV anymore. Now we take all our behavior across different fields or in our social lives at home and we bring them to work. So let's say that we communicate with our friends and colleagues using Kakao in Korea, FaceTime in US, WhatsApp in Europe, with our friends and calling and voice calling, and we bring that to work. What does the experience feel like? The experience feels like it's not very seamless. I'm stuck with using legacy equipment. So businesses now trying to find ways to take all these social apps and social devices, commercial grade devices, and bring them into collaborative environments. Desktop PCs, think of the past. Voice over IP phones, think of the past. What type of a work environment am I going to create to serve these individuals? And of course, any of these use cases for students, for doctors, for enterprise, for visitors and customers, if you do not protect privacy, and if you do not protect security of the data, which is where we contribute a lot, which we're going to talk about, then none of this matters. Gen Mobile doesn't matter. If you cannot guarantee security, you cannot serve the needs of Gen Mobile in the enterprise. Now, I talked about the one side of us, right? Gen Mobile, we're interacting with our mobile devices and our consumer-grade equipment. And then there's the other side. we turn around, we put our smartphones and mobile devices and IoT devices down, and we start interacting with enterprise-grade systems, systems that are supported by our IT infrastructure. At that point, we become knowledge workers. We no longer are tied to a manual labor, right? Most of us are now tied to using our brains instead of our muscle to get the job done. In order to do that, we interact with a variety of digital interfaces. At an air traffic control station, air traffic control engineers look at real-time data about flight status, flight times, on digital interfaces that are powered via a private data center in that air traffic station. Next, if I'm a creative person at DreamWorks creating the next animation movie, I am interacting with a digital interface supported by my IT team that talks to a private data center at high speeds, high computing power. If I'm an engineer, let's say at Max Planck Institute, happens to be an HPE customer, and need to run a simulation on a big theory, to prove a big theory, then I'm relying on my private data center resources. If I'm a financial analyst at Pacific Life, for example, which we highlighted on the wall, I need to look at financial loan information, financial data in real time to be able to make the best business decisions for the day. If I am Levi's across serving 30 different countries, 500 different stores, and if I need to push advertising to digital screens in my stores in real time, very quickly from my own private data centers, then I need to do that in scale and very easily from a central location. And this is all mandated to us by this idea of a knowledge worker. We are Gen Mobile, interacting with commercial grade devices. We want to bring them to work. But in addition, we demand that the interfaces that we use, the data that we touch, also takes place on digital platforms that are managed by IT, because we are now knowledge workers. Does this make sense? The demands and the use cases of individuals, workers, are the starting point for any networking project today. Okay, so that's pressure point number one, people. Next, devices. I do not think that any of us in this room back in 2005 have predicted that the iPhone will be a reality. None of us did. We never predicted that we will be able to actually touch our phones. Nobody predicted that. And that perfect storm continues since then. Just like we did not predict iPhone, we did not predict that we will talk to a device that sits on a counter and we can buy things by talking to it. We can talk to Alexa and say, Alexa, get us some more baby food. And baby food will ship to your house. Nobody predicted that. Nobody predicted that the motion sensing video cameras can be deployed in masses in a variety of different networks just under a couple of tens of US dollars. Nobody predicted that I can actually interact with physical spaces around me, like secure areas, using connected doors, where I can pull up my phone, the system can identify where I am, who I am, read my fingerprint on my phone, and open that door for me. Nobody predicted that that would be possible. And the list goes on. Right now, we call that IoT. Right? Tomorrow, there will be something else. IoT will become BOT. Right? The trend here is the end user devices that we interact with, the things that connect to the network, are no longer predictable. We cannot predict what's going to connect on your network. So it's chaos. I call it the perfect storm, but it's a bit chaos. Now, imagine this in a previous life. Desktop PCs, voice over IP phones, printers, applications that run on your IT server rooms, they were all managed by you. You actually upgraded the desktop PCs, the operating systems. You installed the antivirus software on each and every one of them. You actually pushed a new firmware release of the voice over IP phones. You managed which printers would connect to which ports and when. Those days are gone. The perfect storm is here. It's chaos. Okay? So that's pain point, market trend number 2. The third one is the reality of who actually gets to initiate an enterprise networking discussion. Who actually decides that we need a new networking project? In the past, this was based on IT networking principles. We would say, you know what, we need more ports in this building. Let's pull 50 more switches. Let's upgrade all our routers. Let's buy more capacity for our core. That was easy because IT networking was relatively easy with wires and ports and VLANs. Things were static. Things were not moving. Nobody brought their desktop PCs from home. Nobody took their voice over IP phones to home. Things were predictable. Now, we have this situation. One day, your chief digital officer can wake up in the morning and say, I'm going to take our patient registration system in our hospital and turn that entire system from paper and pen to digital. Because he's a CDO, Chief Digital Officer, he will just make that decision. He will never ask the opinion of IT networking teams. He will not. He will just make the decision and he will say, networking, please support that initiative. Workplace productivity team, digital collaboration team will wake up one morning and say, we are moving away from wired voice over IP phones and we're moving towards mobile UC, Skype for Business, digital collaboration. And they will not think about IT networking. IT networking just has to support it. I mean, it's a reality that as networking folks, we don't wake up in the morning and say, you know what? It will be much more productive for our employees to work in an open workplace, to collaborate using, social tools at a much more modern work environment. We just don't think like that. That's not our priority. But your facilities teams and your HR teams will wake up in the morning and say, that's what we want, because it helps us save real estate costs and improve productivity for the workplace. After they decide that that's the direction they want to take, they will ask networking teams to support it. So the third trend is the business leaders. First, the behavior of the people at work, the type of devices they interact with, the chaos that it entails. And number 3, who actually initiates a conversation about new networking projects? So these 3 market trends that we see across all verticals, in our mind, causes 5 requirements for IT networking. And I'm going to double click on each and every one of them. So the first one is pretty straightforward. We have lots more devices connected to the network beyond what's on the wired network. We have lots more devices on Wi-Fi. How are we going to manage all this? You used to have 3 network operations team members 3 years ago, and you still have 3 network operations team members. So you're going to be able to do more with less. How can we help you achieve that? We're going to talk about that. The next one is regarding mobile UC. We got to get ready to support mobile UC. So a quick show of hands, please. A quick question, quick show of hands. How many of you have used Kakao, your favorite social chat app, or WhatsApp or Apple FaceTime every single day last week to call or communicate with your family and friends? Raise it high, please. Okay, great. How many of you used a wired phone every single day last week to do the exact same thing with the exact same people? Two. Two here, three here. Okay. You see the difference? You see what I mean? You are Gen Mobile. You are a knowledge worker. Your behavior needs to be supported by IT networking teams. Another question for you, which is the third topic. The topic about security. Who controls the data? Who controls the operating system? How many of you, again a show of hands please, how many of you have called your IT security team, your cyber security team and said, I am going to upgrade to the next version of Android or iOS. Can I get your approval? Can I do that? How many of you actually asked for permission before you did that? Zero. This is a nightmare for cybersecurity teams. Okay? In the past, they used to control everything. They used to push firmware. They used to push operating systems, antivirus checks to everybody's digital device. Now they have completely lost control. Okay, we're going to talk about how to solve that problem. Number 4 is something that Rohit also mentioned. I'm mobile. I'm carrying this device wherever I go. It's already in my pocket. I just took a picture. I want that remote access wherever I go. Can I enable that for enterprise networks, just like it is the case for LTE, cellular networks? I'm going to talk to you a little bit about that. And lastly, indoor engagement. Lastly, improving workplace productivity. Now the question there is, again for you, again a show of hands, how many of you use GPS, locationing technology outside while driving, trying to find things frequently? Every day, every 2 days. How many of you use outdoor GPS? Raise your hands, please. Okay. Can you do that same thing indoors today? Like, can you find restrooms, restaurants, things around you, where the demo stations are, get information about your environment indoors as much as you do for outdoors? The answer is no. You can't do that. You cannot. You don't have a way to interact and learn about your physical spaces. It's kind of ironic because most of our time is actually spent indoors, but we can actually gain more information about outdoors on our smartphones than indoors. It's ironic. So we offer to change that. We have a solution to enable you to interact with the physical spaces and gain information about your whereabouts, your physical environment, just like you do it outside. Let's dive right into it. The first piece is the infrastructure. What are we actually deploying? This is our differentiation. I'm going to give you a little bit of perspective about what actually our product portfolio is. First of all, the approach is to go from supporting cubicle farms to open environments, whatever they might be for education, enterprise, hospitals, and healthcare. During that transition, we want to build networks that are not tied to individual pieces of equipment, one set of hardware for remote, one set of hardware for branch, one set of hardware for wired, one set of hardware for Wi-Fi. We don't want that. We want to give you one set of hardware that you can program using SDN. You deploy wired, you deploy it in the remote location, branch location, in somebody's home, in an enterprise, large campus, small campus, and you program it on an ongoing basis. It's the same exact hardware, Wi-Fi and wired, managed uniformly. That's what we want. It's much easier to deploy that way. It's much easier to support it that way. In the past, desktop PCs, voice over IP phones, all they needed was a VLAN to function. But this mobile device and any type of IoT devices, they run multiple operating systems and applications. So in the new world of networking, some people call it contextual networking. Some people call it SDN networking. But ultimately what it means is the network needs to know who is connecting, using what device, what type of apps are running on it, what kind of security and quality of service you need. Network needs to understand that beyond just understanding ports. And as you migrate from old to new, You design networks for the past, and now you're trying to get them ready for the future. As you're doing that transition doesn't take place overnight. It doesn't take place just replacing thousands of hardware components and just waiting it to be done. That takes months. That takes budget. That takes money to achieve that. So what do we offer? We give you multi-vendor management, policy, and a variety of other software components, multi-vendor, that you can look at your past infrastructure and future infrastructure at the same time. This is in Aruba's DNA. This is in HPE's DNA. Many of our software platforms in the campus and in the data center are multi-vendor for that reason. Product portfolio looks like this. I'm not going to give individual details of the products, just to give you a kind of a snapshot of the things that I will refer to in the next couple of slides. Infrastructure is made up of 2 wireless technologies, 11AC Wi-Fi, and Bluetooth low energy beacons. So we're in the wireless business, but we're in 2 wireless business, Wi-Fi and Bluetooth. Wi-Fi gives us data access, data transactions. And Bluetooth gives us the GPS, indoor GPS. Just like on the outside of this building, you would use LTE for data and GPS for GPS. The data needs to transfer through the wired network, connecting back to your core and DMZ and the internet. Wired network infrastructure is there to support it. Unified management, unified policies between wireless and wired. Multi-vendor software controls, which we're going to talk about for management. Policy for BYOD, IoT, and location-based services. And the secret sauce. Centralized control for wired and Wi-Fi. That's where the SDN magic happens. That's where we identify users, devices, and apps. That's where we control how users roam. That's where we control the performance of wireless networks. And that's where we identify all the apps that we need to prioritize over the infrastructure. So we have infrastructure components that are unified at any location that you want to deploy, and software components that make that stuff work. All right, so I'm going to go deep. Taking a little bit of break. It's getting hot in here. Can you guys feel it? Oops, I guess I cannot. I'm getting there. I'm getting there. There we go. Better. Okay. We're gonna go deep. So I need to get ready. I need to get ready for the battle. Okay. We're gonna talk a little bit technology now, because we're gonna talk about how we solve some of these challenges. The first challenge is on the wired network. The wired network as we know it is changing rapidly because of the arrival of these devices. We don't know what these devices are half the time. Our facilities teams and HR teams and sometimes the end users bring them and connect to the network. Apple TVs, looks like you can talk to an Apple TV now. Connected doors, video cameras, and usually these devices update themselves from the cloud. So sometimes you don't even have the opportunity to manage them because they are sometimes provisioned to update from the cloud automatically. I mean, talk about end users upgrading their smartphones to the next generation of operating system. These devices do it themselves without your knowledge. So our first job is to make sure that when these devices connect on a wired network using this tool called ClearPass, we profile it. We identify the device type, the operating system, where it's connecting, what it is. Just tell me what it is. And that communication happens on an ongoing basis, constantly, 24/7. We monitor these ports. Whatever connects, we apply a policy to that port. If you want that traffic to be tunneled to a mobility controller and inspected, policed, we can do that. You can say video cameras, when they connect to a wired port, police them. And assume that you deployed thousands of these devices. You have 1,000 connected doors in your environment. They're all secured. Door locks are connected to the network. They're secured using your infrastructure. There's traffic being inspected by your favorite security solution. Let's say that something goes wrong after the last software update to these devices. After the last software update, these devices start misbehaving. They start scanning your network. They start sharing information with different parts of the internet that they're not supposed to. So what can you do? Their misbehavior are detected via your security system. Your security system talks back to ClearPass and say, please take action on all the IoT devices that are misbehaving automatically. So as soon as a type of device starts misbehaving on your network, we automatically take action. No IT ticket, manual labor required. We call that colorless ports. In the past, we used to assign colors to different VLANs, right? We don't need to do that anymore. You connect the device, we detect what it is, we apply a policy. We detect the health of that device. Thanks to integration with third-party systems, we change its personality on the port. Reduces significant amount of time on your infrastructure. Next is Wi-Fi. There's a problem with Wi-Fi that nobody wants to talk about. The problem with Wi-Fi is mobile devices, as smart as they can be, they're not very smart when roaming. They cannot roam in a smart way. In Wi-Fi networks, traditionally, mobile devices used to decide where to connect, which access point to connect. But usually, since they are commercial-grade devices, they do not make the right choice. They do not pick the best access point. Plus, they don't even know what's happening in the rest of the world, rest of the network, to pick the best access point. So what do? We have converted our Wi-Fi infrastructure to be just like the cellular networks. As you're driving on the road at 60 kilometers per hour, your phone roams from one base station to another base station as a result of the cellular network telling your mobile device to roam from one to the other. We do the same thing on Wi-Fi. We decide when a mobile device needs to roam from one access point to the other. Our unique client match technology enables that. Centralized control of roaming improves predictability of Wi-Fi performance tremendously. But what if client match is not enough? What if I can actually predict the future for Wi-Fi performance? I cannot predict what type of smartphones are going to come out next year, but maybe I can predict the Wi-Fi performance. Here's how we do it. New technology called Clarity. It's called Aruba Clarity. It really clarifies things for many of the network operators. As devices connect, we monitor how long it takes for them to get a DHCP IP address, how much there's internet latency in the WAN backhaul. We get information about how much it takes for those devices to authenticate to the backend infrastructure. And we monitor that over time. In Airwave, we give you reports on how fast or how slow your network services are. Internet, WAN speeds, LAN speeds, DHCP, DNS, radio servers. We actually display all of that information. As those parameters, as those metrics starts getting worse, we notify you. We say, we're operating under really not ideal numbers. Things are getting worse. Nobody's complaining yet. Nobody has called and said, my Wi-Fi performance is slow. But you can see that things are going in the bad direction. So you can start predicting network issues before they happen. Network troubleshooting becomes a thing of the past. You don't troubleshoot, you predict. What if there were no mobile devices? What if it is Monday, 5 a.m. in the morning, for example, this morning, before you all showed up? How can I test the infrastructure to make sure that it's ready for you to connect? How do I do that? I probably send somebody over with some laptops and devices, test the Wi-Fi performance, and I do it at every single site. What if I told you that you can schedule tests at different locations in your environment, in the campus, across many different branch locations, on demand, at a certain time, to test itself? What if the access points can talk to each other and test the performance of back-end systems every scheduled time that you put on the calendar? And maybe every Monday morning at 6 a.m. you get a report in your email that says everything is good to go. Users can connect. That's clarity. Next up, let's talk about apps. We talked about mobile UC. The premise here is I have many apps operating in a very small device. In my smartphone, I can have Dropbox, file sharing, a FaceTime call, podcast updates, all at the same time on the same device while I'm on the Wi-Fi network. And sometimes different apps mean different things for people. For example, maybe I'm okay with my CEO, the president of the company, watching YouTube videos once in a while on the Wi-Fi network and taking up all the bandwidth he wants because, you know, he's the CEO, he's the president. But maybe I'm not okay with my guest users or maybe some of my employees doing that. Maybe I'm not okay with some of the Android devices accessing my corporate data applications because I'm not sure about how healthy some of the Android versions are. Maybe Android 4.0 cannot access my corporate directory, but I'm okay with Android 5.0 accessing my corporate directory because I trust its security profile. How do I manage that policy? If I were to manage that policy based on VLANs and ports, imagine the number of VLANs that we're managing. It's just impossible. So what do? In our SDN controllers and mobility controllers, we implement application-specific policies that the wired and the Wi-Fi network can understand. We literally say, here's the role of the user in the organization, here's the operating system on the device, here's the application that we're talking about, here's their location, and here's the time of day between 9 and 5. This policy needs to be approved at high quality in the infrastructure. Once we set that up, wherever that user goes, wired network, Wi-Fi network, remote location, campus location, that policy is adhered to. So we program the network in real time for different users, devices, apps. That flexibility is what you need to ensure that applications like Skype for Business get the high quality that they need because we only have so much oxygen, we only have so much airtime to share. Once we ensure quality of the infrastructure for different apps, using tools like Airwave, we actually report back on that quality. We tell you how good quality your Skype for Business call was, how good quality your headphones were that you were using during the call, how many other devices were in the same conference call with you, and how their quality was during the call. We centralize that visibility so you, as networking teams, can prove back to the business that when we implement strategic applications like Skype for Business, you can prove that the network infrastructure was ready and did what it's supposed to. Everything was at high quality. Okay? Let's talk about device security. So, as I mentioned, these devices cause a bit of a chaos on the network. We really don't know when they're going to be upgraded and what type of apps they're going to be running on an ongoing basis. And since cybersecurity teams do not have tons of manual labor, they do not have the time in the day to go and check everybody's device every single morning. Since we don't have that, we need to automate that problem. Here's how we do it. Again, it starts with ClearPass. On any switching infrastructure, on any Wi-Fi infrastructure, this is possible. ClearPass onboards these devices to the network after detecting what they are, assigns them the right set of policies. When these devices are out of policy, it starts doing IT's job and automates their health check and quarantining and bring them back to life on the network. Let's assume this. I have a BYOD or a corporate-owned device. It's managed by MobileIron, MDM. And at the time of connection on a Monday morning, MobileIron MDM detects that the certificates on that device is no longer valid. And that device should not get the same level of network access that it was supposed to. MobileIron notifies us. We can go back out to a tool like PagerDuty. We can notify your IT security team saying, this specific device owned by this specific user is actually out of profile right now, automatically notifying them. We can send an SMS message to the end user using Twilio that says, your device is now out of corporate policy. We should bring it back to a healthy state again. You need to follow the instructions that we send you shortly. And in the meantime, if that device starts accessing sites, websites, internal resources that it's not supposed to, because possibly there's a malware running on it, these solutions can detect, log that incident, and we can take action back on the network. So ClearPass's job, number one job, is to translate what your security infrastructure and systems need from the network and vice versa. It acts like the translator. It acts like the place where we automate security operations. Next, let's talk about branch and remote. I told you that I was going to highlight how we can enable cellular network-like behavior from enterprise networks. Imagine this scenario. You have your laptop and your smartphone. You're at work. You're connected to a secure Wi-Fi infrastructure. And maybe sometimes you connect to a wired network too. You take those devices and you go to a branch office in another city, in another country. You plug them in, you open them up, and they connect immediately. The Wi-Fi network is available for you wherever you go. You take that and you bring it on a temporary office location, or you go to one of your colleagues' home, and you open your laptop, you open your smartphone, and again, it connects securely to the enterprise network. Maybe you're on your company's bus, company bus, that transports people from A location to B location. You open your laptop, you open your smartphone, there is the enterprise network. This is actually possible and enabled by many enterprises that we serve. They invest in our remote access point solutions that can also support 3G, 4G backhaul for internet, offer wired and Wi-Fi services on a bus, on somebody's home, in a temporary office location, at a branch office. Enables the exact same network, exact same security at small sites. Then I can expand that. I can deploy more than one access point as a cluster. I can deploy wired and routing solutions to expand that small office to a large branch office for tens of people. Then I can take those branch offices and deploy that across broadband. Maybe I'm moving away from MPLS. MPLS is way too expensive for my needs. Maybe I'm moving heavily towards broadband internet. I can still enable the same functions using Aruba's branch gateways, 7000 series. And all of this equipment can be deployed with zero touch using Aruba Airwave. You take them out of the box, controllers, switches, APs, you plug them into active internet connections, they download their configuration from your private data center. They automatically connect to your private and public services such as voice calling, video calling, content filtering, security infrastructure. They deployed zero touch. The end user, the guy who's driving the bus, you at home, you do not configure anything. You just plug and play. Last piece of the puzzle for campus. Software controls for mobile engagement. This is my favorite topic, bringing back to the discussion about Bluetooth and indoor GPS. This is the piece that enables indoor GPS capabilities for many enterprises out there. Customers include people like San Francisco International Airport, Orlando International Airport, so airports are definitely a big target. Healthcare organizations like Boston Children's Hospital in the US, museums in US and Europe. And the main goal essentially is to ensure that people running iOS and Android operating systems on their smartphones can take advantage of indoor GPS capabilities. And here's what that means. At the heart of it all, there is a Meridian cloud-based app platform. Meridian is like Google Maps, but for indoors. It's like Apple Maps. You open up Meridian, you enter your digital map information for your venue, for your workplace. You give us the AutoCAD files, we convert those AutoCAD files to Google Maps-like indoor maps that you can easily see and navigate on a smartphone. On top of that map, using Meridian, you can also create specific place marks, create specific locations, mark different physical spaces. You can create wayfinding directions on that map. You can say, if somebody wants to go from here to here, here's the most applicable path. In addition to that, using the same platform, you can start managing our indoor GPS hardware, which is Bluetooth beacons, BLE hardware. You deploy BLE beacons using a very simple to use mobile app, and you deploy them wherever you like, of course based on the reference design. And then they are centrally managed from Meridian using Aruba sensors or Aruba access points. And here's how that works. Traditionally, if you deploy BLE beacons, they last about, since they are battery powered, they last about 6 months. So after 6 months, BLE beacons usually tend to run out of battery. Not in our case. Our battery-powered beacons run up to 5 years. 5 years. Not 6 months, 5 years. 10 times longer than traditional beacons. That's one. But we still believe that they need to be centrally managed so that we can update their software, push new capabilities to these beacons, manage their status from a central location. No other solution in the market today offers an indoor GPS solution with Bluetooth that is centrally managed. No other solution. We're the only ones in the market. These guys talk Bluetooth. If you have a Bluetooth-enabled Aruba access point, you can listen to those signals and transfer data over to the Meridian. If you run a multi-vendor infrastructure, let's say that you operate a Cisco Wi-Fi environment, we can deploy Aruba sensors, listen to Bluetooth, package that data, send it over Wi-Fi to an existing Wi-Fi infrastructure. So Aruba sensors can act like the gateway between beacons and others. Once this infrastructure is set up, once I am managing the beacons, I'm managing the digital maps, I'm managing the content on it, now I'm ready. That's the part that as IT networking people, that we take care of. The management, the setup of the infrastructure. After that, it's between the end users and the app developers. For all of us, if we're going to use a mobile app, we want to make sure that it's usable. If a mobile app is not usable, what do? Delete immediately, or we just never go back to it. Traditionally, if a brand builds a mobile app, among all its community members, among all its audience members, attach rate is 5 to 10%. So if I release a mobile app today for this audience, only 5 to 10% of you will actually download it and use it. That's the metrics that industry is dealing with. In order to make sure that that number is higher than just 5 to 10%, these app developers need to design a very beautiful app that you can interact with your space, with your environment. Meridian platform gives you a standard tool set to build your own app if you wanted to. Many of our customers, like Orlando International Airport, Nebraska Furniture Mart, they are actually using our app development kit and build their apps using our tools. But many of the organizations, they choose to integrate Meridian into their existing apps. So for example, this hotel chain, Intercontinental, they will build a mobile app to interact with their audience. In order to enrich that experience, they will take our digital maps and they will put it in their existing mobile app that they already distribute. So this enables them to interact with people in a much more meaningful way in indoor physical spaces. And anything that you do outdoors using outdoor GPS becomes now possible indoors. Finding your way, discovering things around you, finding your friends by sharing your location with your friends, finding meeting rooms, automatically booking meeting rooms, etc. All right, so that was mobile first. Hopefully that makes sense. Those are the 5 pieces of problems, headaches that we solve with those aspirins. Next up is cloud first, the data center. So the requirements for networking in the data center are somewhat different. They're not end user facing. They're not mobile device or IoT facing. But they are significant in terms of our ability to address. Because any type of data center operation takes a long time given just the nature of how data centers are built and maintained and how much budget they require to upkeep. First of all, our recommendation is if you're going to deploy, if you're going to move to virtualization, server virtualization, if you're going to move to microservices or containers, you have to automate your network operations first. Do not let your application development teams invest in new applications, new way of deploying virtualization solutions without figuring out the automation of the network ops. As soon as a new app is deployed in the data center, your network needs to adapt. It should not require manual moves as it changes. So I'm going to talk to you about how we can enable that experience. Secondly, you only have so much real estate to deal with. You only have so much budget for power and cooling to deal with. So you need to be able to always do more with less. As the data needs increase, as you move from a 100% private data center to more of a hybrid cloud infrastructure, you will still, at some point, run out of bandwidth and capacity in your own private environment. So I have the same amount of space, same amount of power and cooling budget. What do? Well, you can move to a greater level of network capacity, greater level of network interface capacity on your servers and your storage equipment. So that's the move from 10 gig interfaces to 25 gig interfaces. I'm going to talk to you a little bit about that. Next, consolidating networking for servers and storage in order to reduce OpEx is one trend that many of our customers have embarked on. Traditionally, in the data center, you have IP server infrastructure that is connected to Ethernet, traditional IP routing, traditional IP switching. Then we build storage area networks, and we started using fiber channel as a transport mechanism. And back in the day, when the data growth and the needs from the data center were relatively limited, it was okay to manage two separate networks, Ethernet and fiber channel. What if I were to told you that using FlexFabric 5900 CP switches that you're going to hear more about today in the Cloud First Networks session, you can actually consolidate network ops for both systems into one top-of-rack environment. You have the same exact storage area network and IP-based network. You might be moving away from storage area network to IP-based storage, but that's not going to happen over time. You're still going to maintain two separate networks. What if we can consolidate that and reduce our OpEx? That's the third recommendation that we have for our customers. Next, your data centers are not going to be static and maintained in just one single location. They're going to be maintained across multiple geos. I mean, we're all mobile, right? We cannot support our global business, and we cannot meet regulatory requirements that Rohit mentioned by just serving all the needs of our corporate from just one single data center, or at least a redundant pair of data centers. We have to replicate, we have to expand as we move to a hybrid model. But replicating and migrating data centers traditionally cost a lot of dollars. Dedicated MPLS links, high bandwidth MPLS links for high quality transfer. There's a specific technology called EVI, Ethernet Virtual Interface, that allows FlexFabric switching equipment to replicate data center, to enable data center migration over broadband, high-speed broadband links very quickly. That data migration can happen automatically and managed from HPE's management platform called IMC. That disruption-free data center migration is key when we're not taking the network out of service, data services out of reach. And last but not least, the fifth recommendation that we have for IT networking teams, something that Rohit mentioned, is as you embrace SDN, as you embrace deployment of more apps and different type of solutions such as containers, your DevOps teams, your app development teams are going to ask for more flexibility. They're going to say, why don't you give me a networking equipment that I can program on demand? Why don't you give me a networking device that I can configure myself? I don't have to wait for a network operator or a network vendor to deliver me an operating system. Why don't I write my own tools on an open source operating system running on the hardware? What if I program the operating system the way I like it? What if I use the NPUs and the CPUs on the switch the way I like it, not the vendor, so that I can touch thousands of apps in real time? JP Morgan Chase, one of our customers, large financial firm, they have thousands of developers releasing thousands of apps every year. Thousands of apps every year. And they're using this model where they decide what the network stack would look like. So these are the 5 requirements in the data center. Our approach is, again, comparing the legacy system to more of a networking infrastructure that's ready for a hybrid deployment model. In the past, if you look at the legacy infrastructures, if you wanted to apply a new security policy, new quality of service policy for different apps, and servers and containers and microservices in this legacy environment, you would replace the hardware, the switching hardware. You would go from X model to Y model. You will actually replace the hardware. We believe that you should not have to do that. In order to enable redundancy in the data center switching environment with top-of-rack switches, with core, we believe that you should not be making those redundancy changes manually. We believe that as soon as the switches are connected to the infrastructure, they should be able to discover themselves, form a cluster, and enable redundancy automatically. Redundancy should be baked in to the infrastructure itself. It should not require extra configuration. And lastly, the software tools that you use for server, storage, networking should be multi-vendor, because your data centers are multi-vendor. You are using multiple server equipment. You are using multiple networking infrastructure and storage environment. You cannot assume that every single equipment, even if we, as HPE, we sell an end-to-end solution, you cannot assume that all should be HPE. It cannot. You have certain amount of budget requirements and certain amount of timeline that you have. So in our approach, we provide software tools like distributed cloud networking, DCN, HPE DCN solution. That's our software-defined networking solution in the data center. That platform talks to a multi-vendor network infrastructure, Cisco, HPE, Arista, others, and applies quality of service policies and security policies in real time. You change the deployment model for an app, the network adapts in real time. The fabric, the data center network infrastructure, is no longer just switching, but it actually has the fabric. You can program it in real time. And that fabric is highly available. With a technology called HPE IRF, Intelligent Resilient Framework, you can actually deploy switching infrastructure and have them enable clustering, share configuration, share network state automatically. And the software, management software platforms are multi-vendor. And I'm going to talk to you a little bit about what those are right now. The infrastructure is made up of Flex Fabric and Alto line switches, which you're going to hear more about today if you join the Cloud First Networks track. More important for us, as I mentioned, the DCN is our software-defined networking platform. Apply quality of service and security within the network. HPE Helium OpenStack, that's where the policy definition takes place. That's where the management of the entire infrastructure takes place for servers, storage, and networking. And both of these platforms are multi-vendor. That's what manages the infrastructure in the data center and apply SDN policies. And then there's IMC. IMC is your standard network management tool for data center and campus switching, but more, because it offers multi-vendor controls. So you might have a mixed network environment today, and you want to apply configuration changes, look at your topology views, do FCAPS type management model. You do not have to replace every single networking equipment in your environment to move to this model. You can start with IMC. IMC manages your existing Cisco infrastructure, HPE infrastructure, Juniper, Arista infrastructure, and then you can change switching environments in your own terms. So that's the Cloud First Network portfolio. Be sure to spend some good time on the platform. One thing I want to highlight here is the data center economics before I close. With 25 GE, we've looked at some hard numbers. We said, what is it, why do we invest in this high capacity solution? And across the board with our server teams and ProLine team, looking at our interfaces, even cabling, you can come to HPE and say, I have a 10 gig infrastructure today. I would like to move everything, transceivers, cabling, switching, server interfaces, all to 25 using my existing HPE environment. And we can migrate that to you to 25 gig in record time. Same amount of real estate, same amount of power and cooling, but you just get a lot more capacity. Does that make sense? So that you can start using your switching environment and your server environment to its full capacity. These numbers, I think, are pretty staggering. In the data center itself, as I mentioned, you might be working with a variety of HPE solutions. On the ProLine server side, Flex Fabric is tightly integrated. They come as a single reference design. Similarly, for web scale deployments with Cloudline and AltoLine, they come in a single reference design. 3-PAR storage, fully tested, fully operational with Flex Fabric switching portfolio with converged ports. And ultimately, these set of integrations will present itself with the arrival of a new open source network operating system later this year within HPE Synergy, which you might have heard about in the form of composable infrastructure. The key news here is we operate with your existing infrastructure very easily thanks to our multi-vendor DNA. We integrate with that using standard-based protocols. But if you want to go 100% HPE, which we love to do, then you have the reference design and single operating model to take advantage of. And to close, I just would like to remind why we're in this business. We believe that the world of desktop PCs, printers, voice over IP phones are a thing of the past. We believe that our future workplaces, work environments, work lives will be driven by mobile and IoT at the edge. That edge network, the demands of the edge network, the application demands of the edge network will demand further enhancements in the cloud infrastructures in private and public and hybrid. The deployments there, the capacity and the app delivery enabled via the cloud will further drive innovation at the edge. And this vicious cycle is going to continue. And we believe that our networking solutions are best suited to connect the dots between mobile and cloud going forward. So that's it for me today. Hopefully that was useful. Thank you again for your time.